Hi students, welcome to my channel Easy Maths by Uncle. In this video, I am explaining easy and interesting topic types of sets. Actually, in 10th class you are learning 10 to 12 different types of sets, and also in intermediate you are going to learn 3-4 extra sets. That's why total 15 types of sets I am explaining in this. By that, this is useful for 9th class and 10th class also intermediate students. After completing 10th class syllabus, I am going to start intermediate also first sets only. Okay. So for them also this is very useful. So my humble request is please subscribe this channel. By that you will get the notifications for my upcoming videos. Right. What are the different types of sets in this video? Empty set, it is also said to be null set or void set. I will explain with detail. I will give one or two examples also, right? Singleton set, finite set, infinite set, equal sets, equivalent sets, disjoint sets, overlapping sets, subset, proper subset, universal set, superset, proper superset, power set, family of set. Okay? So we will learn about this in detail. Students, come to the first set. It is empty set. Empty set, it is also said to be null set or void set. What is an empty set? A set that does not contain any element. Set that does not contain any element means a set with no elements. So if there are no elements in the set, it is said to be null set or empty set. It is denoted by symbol pi. Okay. This read as pi, phi, not pi. Pi means the difference is there. This one also we can read as pi. Simply pi. This one is pi. Okay. See, in roster form, pi means what? Like this, with empty braces, we have to mention. Don't put 0 here. If you write 0, it is also one of the element. Okay? So, only empty braces we have to mention. This is also symbol for null set or empty set. Otherwise, we can denote with the pi. Right? So, in roster form, we can represent like this. Okay? With empty braces. Now see, cardinal number of empty set, n of pi equal to 0. What is the cardinal number? Number of elements in the set. In empty set, there is no element. So, number of elements, 0. That we can represent as n of pi equal to 0. This n of pi means cardinal number of set pi. So, number of elements is 0. Right? So, negative integers. One example, negative integers in natural number set is pi. Is there any negative number in natural number set? Natural numbers starting from 1, 2, 3, 4, so on. Okay? 0 is not there, even negative numbers also not there. So what I am taking here? Negative integers in natural number set. There is no negative number. Okay? Right. So that is pi. Suppose a month with 35 days. Is there any month with 35 days? It is also empty set. Right? So empty set means if there is no element in the set, right? Now singleton set. What is singleton set? See, if a set contains only one element, then it is called a singleton set. Here there is no element, it is empty set. Suppose if in the set there is only one element, that is said to be singleton set. For that we can write in roster form. Roster form with one element, sorry, in set builder form we will explain. Here x is less than x and even prime number. Even prime number. So prime number list we know 2, 3, 5, 7, 11, 13, 17, 19, so on. In that only one even number is there. What is that? 2. In roster form we can mention 2. This is set builder form, this is roster form. How many elements are there in set A? Only one element. Only one element means that is said to be singleton set. Okay? So n of A equal to 1. Again, what is n of A? Cardinal number of set A. How many elements are there? Only one element. Okay, so we can mention n of A is 1, means set A containing only one element. In A, there is only one element. See, one more. B. Suppose set B. Former women Prime Minister of India. So, Prime Ministers from Jawaharlal Nehru, all are gents only. But ladies, only one woman. That was Srimati Indira Gandhi. Okay, Indira Gandhi was only one woman ruled India. So, Prime Minister list we will get only one element, Indira Gandhi. Okay. So one more example I have written here. Number of women bird. How many vowels are there? I. It is only I. One. Okay, one vowel. It means it is also singleton set. So what is singleton set? A set with only one element. Right. We will go to third one. Now students, what is finite set? What is infinite set? See, finite set. If there are countable number of elements in a set, it is said to be finite set. Means in a set, if the elements are countable. See, for example, vowel set I am taking. A, I, O, U. Only 5 elements are there. So cardinal number of V is 5. This means what? In vowel set there are only 5 elements. That is finite set. Next, A. X is such that X belongs to A and X is between 1 and 100 including 1 and 100 also. See here totally 100 elements are there. 1, 2, 3, 4 up to 100. Okay, we can read this one. 1 less than or equal to X less than or equal to 100. So in natural number list we are taking only 100 elements. That's also countable. Okay, that is finite set. Now suppose in your class total students. So all students in your class, either 50, 100 or 200, that is also countable. Okay, we can write so many examples for finite set. English alphabets A to Z. Okay, now suppose population of village, in a certain village 300 or 500 people are there, we can count that number, right? Now only boys in 10th class. Next, number of pets in your house. So number of small families in a town, all these are countable. Okay, so countable means in a set number of elements are countable. Opposite, see here, infinite set. If there are uncountable number of elements in a set, it is said to be infinite set. So in infinite set we can't count the total elements. For example, natural number list. Everybody knows natural numbers 1, 2, 3, 4, 5, so on. These are uncountable because there is no n number in natural number list. Like that, integers Z or I symbol. Okay, 0 plus or minus 1 plus or minus 2 plus or minus 3, so all numbers are there, positive numbers and negative numbers. That integer list also uncountable, right? Suppose multiples of 5, 10, 15, 20, 25, so on. Prime number list is also uncountable. Even number list, odd number list, all these are infinite sets because the elements are uncountable, right? Okay. Students, now we will discuss about equal sets, equivalent sets. See, what are equal sets? If every element of set A belongs to set B and every element of set B also belongs to set A, then A and B are called equal sets. It means all the elements of set A are also elements of set B and all the elements of set B are also elements of set A. Right? See example. A, here earth, that letters we are taking E-A-R-T-H. 1, 2, 3, 4, 5. That 5 letters E-A-R-T-H. Now what is B? Heart. From heart word we are taking letters H-E-A-R-T. Here also 5 elements are there. But if you compare this, E, here and there E is there. A-R-T-H. So whatever the elements in A, all elements existing in B also. Now all elements of B are also in set A. That's why we can say set A equal to set B. A equal to B. Simply we can write A equal to B. Okay? See, I will write one more example. Suppose P. It is 1, 2, 3, 4. Okay? 4 elements are there. Now another one Q. I am writing like this. 4, 3, 2, 1. Okay, here 4 elements 1, 2, 3, 4. Same elements in Q also 1, 2, 3, 4. Right? So here we can say P equal to Q. Right? We can write another one like this. A. Set of vowels in English alphabet. Set of vowels in English alphabet. Like this, suppose one set is there. Now set B, I am writing directly A, E, I, O, U. Okay, set B, A, I, O, U. Set A, set of vowels in English alphabet. Both are same thing. Okay, same elements we are having. So here also we can write A equal to B. This is said to be both A and B equal sets. Now what is the meaning of equivalent sets? Two sets are equivalent if their cardinal numbers are same. Cardinal number means number of elements in set A and set B equal. Two finite sets, in other words also we can explain. Two finite sets A and B are said to be equivalent if they have the same number of elements. Same number of elements, not same elements. Okay? See the difference. A. Set A is having X, Y, Z. 3 elements are there. Set B. 1, 2, 3. Here also 3 elements are there. Here 3 elements. Here also 3 elements. Number of elements in set A. N of A. 3. Cardinal number. Now in set B also 3 elements are there. N of B. 3. It means number of elements in set B. 3. Here 3. Here 3. Okay, both are equivalents. So we write equivalent sets like this. A equivalent B. In some books they are representing like this also. A equivalent B. Okay, so general will use this symbol. A equivalent B. It means number of elements in set A and set B are equal. Number of elements equal. Okay, not same elements. See, suppose we can write one more example. See. Set A, I am writing as A, E, I. 3 I am taking. Now set B, I am taking P, Q, R like this. Here 3 elements are there. Here also 3 elements are there. N of A 3, N of B 3. Here also we can write A equivalent of B. Okay. So equal means same elements. Equivalent means same number of elements. Right. Now we will discuss about disjoint sets, overlapping sets. See, what are disjoint sets? Two sets are said to be disjoint sets if they don't have any common element. Say, here even numbers are there. 2, 4, 6, 8, 10, so on. All these are even numbers. Now what is set B? 1, 3, 5, 7, 9. All those are odd numbers. Observe here. Is there any common element here? Here only even numbers are there and here only odd numbers are there. There is no common element. So A and B are said to be disjoint sets. With Venn diagram also we can represent all this. I am going to take separate video for Venn diagrams. Venn diagrams we will take all rectangle boxes to represent universal set. That symbol will be mu. Okay. Just for idea purpose I am explaining. Here one set. Suppose A. What is A? All these are even numbers. Okay, like that. Now here one more set is there. B. Here 1, 3, 5, 7, so on. All those are odd numbers. Like this we can represent A and B disjoint sets because there is no common element. Okay, that is Venn diagram. Now P. What is set P? X says that X is a prime number and X belongs to natural number. Prime numbers. We know prime numbers means 2, 3, 5, 7, 11, 13, so on. And the X is such that X is a composite number and X belongs to natural number. So in set Q, what are the elements? Composite numbers. 4, 6, 8, 9, 10, 12, 14. So these are having more than 2 factors, they are composite numbers. These are having only exactly 2 factors, they are said to be prime numbers. So prime number is not a composite number is not a prime number. So these two, P and Q also disjoint sets, right? Like this only we can represent. In universal set, one set P, prime numbers, and the set Q, composite numbers. Okay? Disjoint sets. Now overlapping sets. Overlapping means two sets are said to be overlapping sets if they have at least one common element. At least one common element. See, I am writing set A. What is set A? 1, 2, 3, 4. I am taking 4 elements. Now observe one more. B. Set B. Here I am taking 3, 4, 5, 6. Like this, two sets are there. Here 3, 4 elements are there. Here also 3, 4 elements are there. These are common elements. So set A and B are overlapping sets. So by Venn diagram we can understand this easily. See here. How to represent Venn diagram? Like this. Rectangle box, this is universal set, will represent as mu. Now set A and set B overlapping. Overlapping means like this we have to represent. Here A, here B. So what are the elements, common elements? 3, 4. First you write here 3, 4 common elements. Now what are elements in set A? 1, 2, 3, 4. 1, 2, 3, 4. Okay. See, observe here. 1, 2, 3, 4 are elements of set A. Now what are elements of set B? 3, 4, 5, 6. Already 3, 4 elements are there. Now write simply 5 and 6. See, set B 3, 4, 5, 6. These are set B overlapping sets. So these are Venn diagrams. In separate video, I will explain in detail. Okay, the Venn diagrams. Now disjoint sets. Disjoint sets means there is no common element in sets. Now overlapping sets, at least the sets having one element as common. Okay, at least one element. Okay. Now students, subset, proper subset. See, what is a subset? Set A is subset of set B if and only if every element in set A is also element in set B. So whatever the elements are there in set A, all elements are existing in set B also, then A is subset of B. In other way, A is a subset of B. If A is an element of A, implies that A is also an element of B. See, symbolically, A subset of B. Set A subset of B. If A belongs to A is an element. A belongs to A implies that element is also belongs to B. Okay, where A, B are two sets. You know natural numbers 1, 2, 3, 4, 5, so on. Whole numbers 0, 1, 2, 3, 4, 5. All natural numbers are also elements of set W. So N subset of W. Similarly, W subset of Z. All whole numbers are in integer list. All integers are in rational numbers. So Z subset of Q and rational numbers are in real numbers. So Q subset of R. Irrational numbers are also elements of real numbers. Q dash also subset of real numbers. Here we are having some problems on this. Suppose A, it is having 1 and 2, two elements are there. How many subsets are there for this set? See, subsets. Pi, all of you remember, null set or empty set. It is subset of every set. In number system, 1 is factor of every element. 1 is factor of every element. For 10, 1 is factor. For 20, 1 is factor. For 70, 1 is factor. Like that. Pi is also subset of every set. Remember that. Next, suppose in a set there is one element. This one also subset of that. Now one more. 2. Here, one element is there in set. This is also subset of set A. And 1 and 2, two elements are there. One set is like this. This is also a subset of A. It means every set is subset of itself. Remember this one also. A is subset of itself. Okay? Every number is factor of itself. In number system we are having 14. It is factor of 14. 21, factor of 21. Like that, every number is factor of itself. Like that, here also every set is subset itself. Right? So totally how many subsets are there? Subsets see 1, 2, 3, 4. 4 subsets are there if number of elements 2. So for that we are having one formula. What is that formula? Number of subsets 2 to the power of n. This is the formula. Here elements 2. 2 square. We are getting 4. Suppose if the elements are 3. Number of elements 3. Cardinal number. Suppose P, Q, R. P, Q, R. 3 elements are there. Then how many subsets we will get from this? To Q, that is 8. We will get totally 8 subsets for that, including PQR. Okay? Same set we are trying for subset also. Okay? Now, difference. What is this proper subset? A proper subset of set A is a subset of set A. Proper subset of set A is subset of set A but not equal to A. Okay? If set B is proper subset of set A. Now we are comparing set B. It is a proper subset of set A. Then all the elements of set B are in set A. Proper subset means all elements belongs to set B or also belongs to set A. But A must contain at least one element that is not in set B. So set A, it has at least one element more compared to set B. Then only we will set proper subset. Observe here. A, it is having PQRs, 4 elements are there. Now another set B, PQR, 3 elements are there. PQR, we are observing here also PQR, and extra S is there. Okay, at least one element is there more. Okay, so here we can say B is proper subset of A. B is proper subset of A. So here pi is also subset of A. Only P is subset of A. Only Q element that is subset of A. Only or only S. P, Q, P or PS. Like that in the problems we will explain in detail. But P, Q or S, that set don't write for this proper subset. So how many proper subsets are there for any set? 2 to the power of n minus 1. So for this set A, how many proper subsets are there? 2 to the power of n minus 1. Here total number 2 to the power of n. So what is the difference for that and for this? Same set we are not to write in this case. Proper subset means for any set don't write the set itself. Okay, that's why one less in this 2 to the power of n minus 1. Right? Here A, 1 and 2 elements are there. Total subsets we are telling 4. Now proper subsets for this set means you write this one. Okay? So proper subsets how many? 1, 2, 3. That is said to be 2 square minus 1, 4 minus 1. So how many we are getting? Only 3 proper subsets. Right? Students, now we will discuss universal set. See, universe. So that contains entire things. So universal set also, it is a set that contains all the elements of other sets, including its own elements. So universal set, that symbol is U, capital U we have to denote. Otherwise, this we have to read as mu. U or mu we have to represent for universal set. Right. Suppose, example, I am considering universal set, that is natural number set. 1, 2, 3, 4, 5, 6, so on. All these take as universal set. Okay, total numbers are there. Now, set A, it is separate set. 2, 4, 6, 8, 10, 12, only even numbers. That is one set. Now B, it is only odd numbers. 1, 3, 5, 7, so on numbers. Okay. Now C, prime number list. 2, 3, 5, 7, 11, 13, 17, 19, so on. Okay, prime number list. That is one set. Now D, 5 tables. Okay, 5, 10, 15, 20, 25, so on. That is set D. See, observe here. Set A, set B, set D, set D, all these elements are there in natural number set. So this we can consider as universal set. Okay. Now we will take one more example. Suppose universal set, that is your school. Okay. Suppose your school is universal set. Okay. Total school we are considering. Now in that you can take A, only 6th class students. Okay. Now B, 7th class students, like that. Okay. Now in this also set P, only suppose teachers in your school. Okay, total teachers, that's also one set. Okay. Now Q, non-teaching staff in your school. Okay. So like that different sets we can take, but all these elements that are belongs to set A, set B, set P, set Q, everything are there in your school, is that not? So this one we can consider as universal set. So every set is subset of universal set. Okay. Set A, subset of mu. Set B, subset of mu. And one more thing, mu is subset of mu also. Okay. So that universal set is also same subset to itself. Already I told that A is subset of A. A is subset of A. Like that here natural number set I am considering as universal set. That is also subset of natural number. Okay. Like that every set is subset of itself. This is universal set. Okay. Now we will discuss superset, proper superset. Okay. 10th class you are having subset, proper subset. In intermediate you are having superset, proper superset also. We will learn this one also. Just quite opposite to subset. Superset is opposite of subset. What is superset? If set A contains all elements of another set B, then set A is superset of B. If set A contains all the elements of another set B, then A is superset of B. See here, A, B, C, D up to Z we are taking set A. Now what is set B? A, I, O, U. Vowels we are taking here. All these elements are also in set A. So A is said to be superset of B. Very simple. Okay. We can tell this one B subset of A. Actually, we learned already B subset of A. Why B subset of A? All elements of B are also elements of set A. So B is subset of A. Quite opposite here. Okay. So set A, it is having all the elements of set B. So A is superset of B. Now we will write one C. Suppose A, it is having 1, 2, 3. Okay. Now set B, it is having 3, 2, 1. What is the difference here? A 1, 2, 3, B 3, 2, 1. Here also just to observe, set A, it is having all the elements of set B is not what? 3 is there, 2 is there, 1 is there. All elements of B are also existing in set A. So here also we can tell A is superset of B. A is superset of B. We can write symbol like this. Right? A is superset of B. Here in both sets, number of elements are equal. Now see. Proper superset. Their proper subset. Like that here also. A proper superset of set A is a superset of A. Same superset of A. But not equal to A. It means we have to reduce one set. What is that set? The set itself. See, X 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements are there. Now Y 1, 4, 9. Square of 1, square of 2, square of 3. Okay, 1 square, 2 square, 3 square. I have taken Y. Now here if you compare, all the elements of Y are also existing in set X. So X is superset of Y. Here, this one only I will write. A, it is having 1, 2, 3. Now for this, different sets are there. A is superset of pi. Pi means that is null set. Right? Now, suppose any set is there having only one element. It is also, here we can write A is superset of this set. Now, A is superset of only 2 you can take. Okay? A is superset of only 3 you can take. Like this we can write. Now, A is superset of 1, 2. A is superset of another set that is having elements 1 and 2. But A superset of 1, 2, 3. Is this right? See, proper superset means you have not to write this one. Subset it is okay, superset it is okay, but proper superset means this one you have to not write. Okay, at least you have to reduce one element there. Then only we will tell it is proper superset. Right? Okay. Students, finally we will learn power set, family of set. Okay. What is power set? The collection of all subsets of set A is called the power set of A. All the subsets of set A. We know how to write subsets of set A. Now it is denoted by P of A. See, suppose set A, it is having elements X and Y. Okay, only two elements are there, X and Y. Now what are the subsets of A? Only X, only Y, X, Y, okay, and pi. Pi is subset of every set. So four subsets are there. Pi, only X, only Y, X, Y. Okay, that is power set of A. Right? What is power set of A? The collection of all subsets of set A is called power set of A and denoted by P of A. Now, number of elements of power set of A. How many elements are there in power set of A? Here, actually pi is one set. This one is also one set. This one is also set. But power set of A means present these are elements in this power set. Okay? Each set is element in this. That's why we can count the sets only. There are elements in this. Pi 1, 2, 3, 4. Okay? So number of elements in power set A 4. Right? So number of elements of power set A is 4. How we are getting? Same formula. 2 to the power of x. So generally we can write number of elements in power set A 2 to the power of x, where x is number of elements in set A. How many elements are there? 2 elements are there. So 2 square we are getting 4. Suppose here 3 elements are there, x, y, z. Then how many elements you will get here in power set means 2 cubed. You will get here totally 8 elements. Okay? 8, listen that. Pi, only x, only y, only z. xy, xz, yz and xyz finally. Okay? Like that we will get 8 elements in power set of A with regarding this formula 2 to the power of x, that means 2 cubed equal to 8. Now what is family of set? If set A contains elements which are itself sets, so in a set we are having some different sets. Okay, so set A contains elements which are itself sets, then it is called family of sets or set of sets. Set of sets. See here set A. In this some elements are there. What are these elements? These elements are again sets. 1 2, this one is one set having elements 1 and 2. 2 5 7, it is also separate set having the elements 2 5 7. 4 6, it is one set. 4 and 6 elements. Now 5, it is null set. Okay. 1 2 3 4. Actually these 4 different sets. Now we are enclosing this in braces. Means we are mentioning these 4 sets again one big set. That is our family of set. Okay, or set of sets. Like that, different types of sets are there. Now in the next video, I am going to explain some operations of sets and also problems. Okay, if you like this video, please subscribe this channel and also comment on that. If you get any doubts, you can mention in that comment box. Okay, right. Thank you.